so we have an array of numbers, and we would like to find all the possible subsets of this array. We're going to kind of handle this problem in two different ways. We're going to go over the brute force method first, and then we're going to use recursion to actually solve this problem, because this problem actually lends itself really easily to recursion. But as always, let's actually take a second to see if we understand the problem. All right. One of the things I do with problems is I always try to work out by hand how I do it, just to make certain I actually do understand the wording and that I'm not missing something. So what do we mean by subset? Okay, so I have this array. It's got 4 numbers in it, and I could break this array into smaller pieces. So for example, I could have an array with nothing in it. I could say I don't want any of the numbers that are in this original array. Just give me a blank array. That's possible. I could have an array with just the 1 in it. I could have an array with just the 2 in it, just the 3, just the 4. All right, I could say I choose 1 digit, that's it. All right, the next layer is I could choose 2 things, right? I could say I want a 1 and a 2, or I want a 2 and a 3, or a 3 and a 4, or a 1 and a 4. Okay, those are all possible. So these are where I choose 2 of the digits that are in the array. Okay, obviously the next layer up is going to be choosing 3. So you could do 1, 2, 3. You could do 2, 3, 4. You could do 1, 2, 4. Okay, so you could just leave out the 3. Okay, and so any way you slice it, we could take these numbers and put them into different combinations. All right, and so these are all subsets of this top array. And so what we're trying to do is we're trying to figure out how many subsets there are. So if I give you an array with 10 numbers in it, how many subsets, how many different ways can we take this array, right, and smush it into its smaller parts, right? Like break it apart like a candy bar. Okay, there's 2 kind of ways to do this, and there's a brute force method, which we're going to look at first, which honestly is actually kind of harder to understand. A lot of times in problems, you do start off with the brute force way of doing things, just because usually that's the easier way to understand the problem, right? Just run headlong at it. I personally find for this one, though, the brute force actually took me a long while to understand. I understood the recursive way of doing this a little bit better. All right, so let's take a look at the brute force way of doing this. All right, let's go over the brute force way. I've got my array here, 1, 2, 3, 4. All right, so what I'm going to do is I'm going to have a variable. I'm just going to call it result, and it's going to have just a blank array inside of it. All right, you can picture that it has a blank array, nothing in it, and I'm going to basically use this as kind of like my scratch pad. As I go through the problem, I'm going to calculate some results. I'm going to throw them into this result variable over here. All right, so I'm going to loop through every single one of my numbers. All right, so I'm going to loop through for my array. All right, so again, hopefully for these videos, I'm assuming you have at least some basic knowledge in whatever language you're using. I do my examples in Python. They work for pretty much any language you want to have them work for. So I'm going to assume you understand what I mean by a for loop. We're going to go from number to number to number. All right, so I'm going to go through each number. All right, so for each number, what I'm going to do is I'm going to actually figure out what the subarrays for it are. So I'm going to have a little temp variable, and I'm going to just make it a blank array. Then I'm going to loop through my result so far. And that's because if you think about this, right, if I pick 1, then I would say, okay, cool, I'm going to start off with 1. So, all right, how many different ways can I do 1? I could just do 1 inside of this array, right? So I can loop through my result and say, okay, cool, I'm going to take this and add it to the result. I'm going to do temp.append. So I'm going to take the temp, and I'm going to say, okay, cool, temp is going to be temp.append. I'm going to add onto this array. All right, and then what am I going to add on this array? I'm going to take the number I got, right, and add it to the result. So for example, I got 1 here, right? I got 1 plus the blank array, which gives me the 1 inside the array. And then I'm going to go ahead and take this 1 inside the array and put it inside the result. So what that's going to look like is, let me get rid of this. So result changes on the first loop. So now result is a blank array, and an array with 1 inside of it. Okay, because for this second for loop, I only had the blank array. There was nothing much else to take a look at. Now things get interesting. So here, right now I've got 2 things. I'm going to go over to 2. All right, now I'm going to go over to 2. So now this number up here is 2. I still have my little like temp empty little array I'm going to use. All right, and then what I'm going to do is I'm going to iterate through what's in the result, the blank array in 1. And so when I do that, I'm going to add that to temp. So temp, okay, dot append. I'm just going to do app, make it a little bit shorter, right? And then I'm going to basically take the 2, okay, because we're on 2 now in the iteration, and I'm going to add it to the first element, which will give me a blank array with a 2 inside of it. And then I will get, I have 1 here, right? So I'm going to put the 2 in there with that. 1 and 2. All right. So as you can see, what I'm doing, I'm sort of building this result over time. So then result will become much bigger, right? It will have the blank array in it. It will have a 1 in it. It will have a 2 in it. And then it will have a 1, 2 in it. Okay, so you see how we're building this. Now, when we get to 3, we're going to take the 3 and we're going to put it in this first one, blank. This one, 3 with the 1, 3 with the 2, and 3 with the 1, 2, 3. 4 with, then we do 4, right? So then so when we do 3, I'll just kind of write it out just to make it a little bit quicker. And then we'll do 1 in the 3, 2 in the 3, and 1, 2, 3. All right, so now we've added those, and then we'll do 4, and then we'll add it all together. So we're kind of building it as we go along. We keep track of our progress, right? And then we have to iterate through result for every single time that we're iterating through each of these numbers. Now, worst case scenario, what's the big O? How well does it scale? Let me make a little bit of room here. Here's how you can think about it. First off, let me actually use a little bit of a different color. All right, maybe we'll use pink. And then we'll say, okay, cool. This for loop at the top, right? So this one right here, original loop, we're going 1, 2, 3, 4. Okay, that will scale with however many items there are linearly, right? So that's n. Okay, so if we do 1, 2, 3, 4, if we add one more number to this array, we're adding 1 more unit of work. So for every number we add, it's 1 more unit of work. So that's n. So this part of the algorithm is n. But what about the other part? All right, because this part actually changes. You might think of this as n as well, but it's not. All right, so remember, let's go through the algorithm again, and hopefully it'll become clear. I'll leave it at this different color. All right, remember when originally, let me go back to the very beginning, the way things were at the very beginning. We started off with just a blank array inside of an array. So when the number was 1, when the for loop was at the 1, how many things did we have to iterate through? Just this one. There's just one thing right here. So we iterated through one thing. After we did that, then the array looked like something different, all right, because we added some stuff to it. So now it had the 1 in here. Neat. All right, cool. Now when we get to 2, we have to iterate through 2 things. Right, makes sense? And then that was fine. But then when we got to 3, then we had way more stuff, right? You see how it's not linear at this point? Because now when we get to 3, I have the 0, the 1, I have the 2, I have the 1, 2. All right? So now I have to iterate through 4 things. So with I have 3, I iterate through 4 things. How many will be for the next one? 8. So when I get to the last number, I have iterated through 8 things. So this scale, if you look, so remember, the big O is about scale. It's about how big does it get as the number of things I put in the algorithm increases. Okay, so we put 1 thing in, we iterate through once. We put 2 things in, we iterate through twice. We put 3 things in, we have to iterate through 4 times. We put 4 things in, we iterate through 8. 1, 2, 4, 8. The change, we're looking at the change between 1, 2, 4, and 8. This looks exponential. Okay, how do I know that? 2 to the 0 is 1. 2 to the first is 2, 2 squared is 4, 2 to the third is 8. So therefore, this part, this section right here, worst case scenario, we will have to, again, with big O, you're not looking at the biggest thing wins, the biggest amount of work wins. Here we do the biggest amount of work because the biggest amount of work will have the greatest influence on how well the algorithm scales. So since this is the biggest part of work, I can just basically say, okay, cool, this part of the algorithm scales at 2 to the n. Okay, if there's one thing, it'll be 2 to the first. If there's two things, it'll be 2 squared, 2 cubed, etc. So therefore, I'm working on n items, and for each item, for each of the n items, I'm doing 2 to the n worth of work. So the overall work that I'm doing, all right, is, drum roll please, at 2 to the n times n. Okay, so the total amount of work I'm doing is 2 to the n times n. I'm iterating through each number in my array, so that's n items. For each number in my array, the worst result, the most of work I'm doing is 2 to the n. However, n many items, I will be doing that much work. All right, so 1, 2, 4, 8, and it'll go up from there. All right, so this is an exponential big O, which is terrible. Okay, which is absolutely terrible. This would not pass muster if we were actually going to put this in some sort of like math application. It would not work. All right, so this will not scale very well. We avoid exponential functions. But there are a couple lessons we can get from this. And when we get to the recursion, we can kind of look at this problem from a different direction. All right, so hopefully that made sense. At least you hopefully understand why is this 2 to the n times n as far as big O is concerned. Let's use recursion to solve this problem. I think if we were to use recursion, actually it makes a lot more sense. All right, let's use recursion to solve this problem. All right, so I've got my array. It's 1, 2, 3, 4. Awesome. All right, let's think of this instead as a tree, right? I want to think of my options. I could choose to not include any number, correct? I could just have a blank array. I could choose 1. I could choose 2, 3, or 4. All valid options. But here's the thing. After I choose, right, a number, I still have other numbers I could choose from. Okay, I could stop here. Okay, I could stop at this level and say, okay, cool, like, you know, what, like having an array with 1 is valid. But I still have to ask myself, what about the other numbers? Like, what subsets would I have of the other numbers? So if we think about this, this is really like breaking it up into two problems. I take the first number and say, okay, I choose the first number. But then the second problem is, what do we do with the rest of the array? Okay, this part. What do we do with that? Whenever you have a problem like this, where it's like, okay, I can break this problem down to where like one part I know. I can choose 1, 2, 3, 4 blank, right? That's easy. I can just wave my hand and do that. The rest of the problem, though, is like a sub-problem. I have to figure out what to do with 2, 3, and 4. Okay, well, okay, that's fine. What we do, once we choose 1, right, then we could still choose 2, 3, or 4, right? We could still choose one of these other numbers after we choose 1. We could say 1, 2, 1, 3, 1, 4. Those are all combinations. And then after we do 1, right, we choose 2. If we choose 1 and then choose 2, what options do we have left after that point? Okay, 3 and 4. So I could do 1, I could do 1, 2, I could do 1, 2, 3, I could do 1, 2, 4. See how that by breaking this down to a tree, we're sort of exploring all the different options that we could have, all right? And so this is a clear sign that recursion is a good way of going about this. Now, how can we think about this recursively? Again, recursion is all about subproblems, all right? I have one part of the problem I can fix, and then one part of the problem I don't know what the answer is, so I'm going to have someone figure it out for me. All right, let me put my array back up here, and let's think about this recursively, like in terms of a subproblem. Okay, another way to think about this is basically like, it's like you're at work, and it's like, well, I could do my job, like this part is my job, and this other part, that's somebody else's responsibility. Someone else is going to have to figure out how to do all that. I can, answer the phones and respond to emails. When a call comes in complaining about a missing shipment, I don't know who's going to handle that. Somebody's got to handle that, but not me. So what we can do recursively is we can say, okay, cool, I'll have a blank on the side, but I'll take the first number. And then somebody else deal with 2, 3, and 4. Okay, I can pick out 1. That's easy. Like, that's not hard to do. But somebody else figure out what am I supposed to do with 2, 3, and 4. Well, then the other person can take this array and say, all right, cool, I've got this array, 2, 3, and 4. I'll take 2 out because that's the easiest thing to do. I'll just take the first number out. And somebody else, you deal with 3 and 4. And we're going to repeat this. I'm going to take 3 out. You deal with 4. All right. Someone will get 4. And, well, it kind of stops, right? Because after we take 4 out, we have a blank array. This right here, this blank array, is basically the simplest, the smallest subset of this array. The simplest one with no numbers. There's no numbers in here. It's just a blank array. All right. You can't simplify it beyond this. This is the simplest form of this array, an array with nothing in it. So once we get to this point, well, then, all right, cool. We can say, okay, cool. I've broken the problem down into little parts. And then we can, as we go along, we can kind of unfurl it and come back up. So, cool. I've got blank. Great. I'm going to go over here and say, great, we'll keep blank. That's one of our options. Cool. Blank is one of our options. 4 is one of our options. Okay, cool. So we're done with this. This will go away. All right, cool. Now we take 3 and we add 3 to our current options. Can take 3 and add to the blank array of 4. Because the problem at the bottom figured out how many different ways to take a blank array and 4 and put them together. You have a blank array or you have 4. Cool. Then that kicks back up to here. All right, you have a blank array and 4. Take the blank array and 4 and then put 3 in the mix. Okay, well, that's not that bad. So I have a 3 by itself, or a 3 and a 4. Then it's like, okay, I've solved that problem. Done. Kick it back up. So hopefully you're seeing what's happening here. Okay, once we broke down the problem to just, okay, here's a blank array, what do you do with it? Well, it's a blank array. There's nothing more to do with it. Cool. Here's a blank array and 4. What can you do with those? Well, a blank array and 4 is just a blank array and 4. Cool. Here's a blank array and 4 and 3. What can you do with that? Well, I can take a blank array, 4, 3, or 3 and 4. Great. Take the blank array 4, 3, and 4, and 3 and kick it up to here. What can you do with 2 with that? So as you can see, we're sort of we're building the problem back up. Another way to kind of think about this, if you want to get real computer science-y, all right, and we always want to be impressive on our coding interviews. Okay, so what we can think about, and this is the way, again, recursion was always difficult for me because I couldn't really picture it. So if we're being computer science-y, what's really happening is that every time we call a function, right, the function calls itself. So we have this function called find sub, right? With this function called find sub, and it takes in an array. Let me make this a little bit easier. Of one, oh gosh. 1, 2, 3. Okay, let's make it nice and easy. All right. So we have this function. All right. What we're going to do is we're going to figure out, okay, what's the base case? Okay. First thing you do with recursion, what's the base case? What's the simplest problem I could solve? What's the simplest version of this problem? Well, the simplest subarray out of any array is just the array itself with nothing in it. Okay, cool. All right. This is my base case. Got it. Okay, but I don't have my base case, so what do? You take the first number, first, is equal to the array at the 0th index, whatever the first number is. Cool. And then, this is where recursion comes in. what's my subproblem? The subproblem in this case, let's take the first iteration, right? We got 1, 2, 3, right? First will become, and I'll put this in blue so you can understand it's not code, 1. All right, that's the part I did know. We'll say someone else's problem, SEP, someone else's problem, is calling this function, find sub, and saying, okay, I know what to do with the 1, I don't know what to do with the 2 and the 3. Here, take the 2 and the 3, and you go figure out what to do with them. Great. After we get everything together, all we have to do, right, is take the first and combine it with all of the subarrays of the second problem. So whatever what comes back from this function call, eventually we're going to loop through it. We're going to use a for loop, and we're going to say, okay, cool. First plus someone else's problem. And then once we do that over and over and over again, we will be able to figure out the what the actual subarrays are. So let's look at this in code. Again, recursion is kind of hard to visualize in a lot of ways. For example, for some people, for me actually, I like to think of it like a stack. And we'll kind of save that towards the end. I want to get to the coding section so you can see it. And then towards the end, if you're interested, I'll kind of go over what this looks like in terms of what the computer is executing. And so that way you have some way of visualizing this. But that's more advanced. So I do want to get into the coding now so you can see what this looks like in Python. And if the more advanced stuff interests you, you can kind of stick around. Hi, my name is Jonathan Hopp, and if you're enjoying this tutorial, I invite you to visit my website, codingyourcareer.com. I've got courses on Java, JavaScript, TypeScript, and all of the famous frameworks like React and Angular, the kind of things you'll need in order to break into the world of tech and get the knowledge that you need. It's even great for people who are already in tech and want to level up their skills. So it's codingyourcareer.com. Let's continue with the tutorial. Alright, let's do some code. So, when doing recursion, typically what I like to do is always think of what's the base case. So, let's ask ourselves the question, what's the base case? Okay, the base case is the simplest form of the problem, alright? If I give you a blank array, like what are the subsets of a blank array? Well, yeah, the subsets of a blank array are the blank array, and that's it. It does not get simpler. There is no simpler form of it. So, what we'll do is we'll say, if you give me an array that's blank, alright? So we'll say if not array, so we didn't actually get an array with anything in it. We'll just give you back an empty array, alright? So here is the simplest set. You gave me, you didn't, there's nothing in here, and so here you go. Here's a blank array, that's it. Alright, so we did our base case. It is very important to have a base case because, like I said, if you do recursion and you don't properly hammer out all your base cases, you will have a function that never stops. Okay, so now we've got, for example, let's say we've got an array 1, 2, 3, 4. What's the simplest way, the simplest thing I can do here? Well, the simplest thing I can do here is just basically say, okay, cool, you give me an array of 1, 2, 3, 4. What's one subset of an array 1, 2, 3, 4? Well, 1. That's the simplest thing. So what I'll do is I'll take the first item from the array, the first element. Okay, so the element at index 0. Okay, cool. So that will be just, I'll put it in the comments here, that's just 1 for the first iteration. And then I'll say, okay, cool. Well, that's the problem I can solve is, okay, I can, 1 is one subarray of 1, 2, 3, 4. But what about 2, 3, and 4? Well, that's a bigger problem, and I can't solve that right now. So I'm gonna let somebody else take over. All right. So I did my job. I'm gonna, do hot potato and give this to somebody else and have them figure it out. So I'll do rest of the subsets is equal to, and then what we'll do is call this function find subsets and hand it off array, and then everything but the first element. So what this does here is kind of like slicing of the array. So what this means is ignore the first element and then do everything over to the right of that. And so you can imagine this, right? Because that way I'm basically saying, here's 2, 3, and 4. Go have fun with this. Okay, so go have fun with 2, 3, and 4. I did my part. I know that 1 is a subarray of 1, 2, 3, 4. Okay, you go figure out what to do with 2, 3, and 4. All right, now this part right here is going to what I call the recursion swirl. Okay, the recursion vortex is the computer will get to line 8 and call the function, right? It will then call the function, find subsets, and it comes back up to line 1. Except this time the variable array will be 2, 3, and 4, right? Then we'll come back here. This will be 2, and then this will be 3 and 4. All right. Then the function will call itself, and we'll come back up here, and then we'll take 3, and then the subproblem will be 4. See how this happens? Then we come back up. The function calls itself again. We have 4, and then the subproblem will be a blank array. Now when we get to here, then it'll be like, oh, cool, we can return this blank array. So this is how the recursion breaks, is that once we get to here, once we get to the smallest subproblem, we no longer have the function call itself anymore. Once the function stops calling itself, then it will come back down after line 8 and continue. So what we'll do is we'll say this, all right? We have the first number. So let's go back to our original. Okay, where we had 1 and then 2, 3, 4. So I can, for subsets, right, I can choose to put 1 in the subset or keep 1 out of it. So for example, I could, if I have like a subset 1, 2, 3, right, I could choose to put 1 in there, or I could choose to keep 1 out of it and just have 1, 2, and 3. These are both valid, correct? I could choose to have 1, 2, 3, 4, or just have 2, 3, 4. Okay? I could put the 1 in, or I could leave it out. Okay? So I have the 1 here, and then I've basically asked somebody else to figure out all the subarrays that you can get from 2, 3, and 4. Okay, go figure that out for me. Great. I have all the different subarrays from 2, 3, and 4. So I have 2 piles. I can have all the subarrays with the first number, with the 1 included. So what we'll do is we'll use Python, and I'll say put the first number in, plus, and then I'll kind of use an inline for loop. I'll do subset for subset in rest of subsets. What the heck does this mean, Jonathan? Take the 1 and then loop through all the other subarrays we figured out and add 1 to them. All right, so picture that the rest of the subsets are like 2, right? 2 and 3, 2 and 3 and 4, 3 and 4. You know, do you see how that works? And then of course there's going to be blank, and then we'll say, okay, cool. Like basically all the other subsets, all the other ways we could do things, and then 3, and then 4. Okay, great. So these are all the ways that we could do things without a 1. Take all the ways we could do things without a 1 and add a 1 to them. Okay, so subset for subset in rest of subsets. Take the number 1 and add to it. So we have all these, and then go ahead and put 1 in there. 1, 1, 1, and then etc. 1. Okay, so these are all the ones with 1s in it, and then take the rest of the subset without the first is equal to rest of the subsets, like we originally had. So all the subsets with a 1 added to them and all the subsets without a 1 added to them. Well, that would be all the subsets, because either they have a 1 or they don't. Okay, so the whole is equal to the sum of its parts. And all we got to do is return with first plus without first. Okay, so all the subarrays that include the first number and all the subarrays that do not include the first number. And those two combined, we will find all the subsets. Let's give this a spin. So we'll do Python subsets. Oops, I gotta put some debug code in first. So we'll do print find subsets, and then we'll do 1, 2, 3, 4, and we'll find out how many we've got. All right, we'll actually print out all the subsets of it. So we'll do Python subsets. Pi. Cool. All right, let's take a look. We got all of them. 1, 2, 3, 1, 2, 4, 1, 2, 1, 3, 4, 1, 3, 1, 4. So we got all of them. Okay, including the blank one. All right, so we were able to take 1, 2, 3, 4 and break it up into every single possible subset. Okay, and with recursion, like you can see how it doesn't take that many lines to be able to do this. In fact, I will leave it up to you as a little challenge. You actually can write this with far fewer lines than what I wrote. I wrote this algorithm more for understanding than I did for like lines of code. Okay, so the purpose here was for you to understand what it is you're doing. Again, the idea is, okay, when we have a recursive problem, what's the part of the problem we can solve at a given step? And then what's the subproblem? The part I can't solve at this moment, I'm going to give it to somebody else and have them figure it out. Once I say, okay, cool, I can take the 1 from this 1, 2, 3, 4, and that's a subarray of this whole thing. Cool, that's easy to do, I can do that. I don't know all the subarrays of 2, 3, and 4. Hey, you go do that. Bob from accounting, you go figure that out. After I figured out all the other subsets, then then basically all the subsets either have a 1 in them or they don't. Okay, it's a binary thing. All the subsets either have a 1 in them or they don't. Take the two subsets, the ones with the 1 and the ones without the 1, combine them together, and bam, I get all of the varying subsets. Now, the next part, this is, I think, should suffice to kind of understand the problem, understand how recursion helps us to solve this problem. If you're still having problems with recursion, the next section is more advanced, where I talk more about what the computer is actually doing. If you're interested in watching that, then please go ahead and continue the video. Otherwise, I think this should be sufficient for most people to understand the problem. But if you want to do something a little more advanced, we'll talk about activation records and what the computer is actually kind of doing when it's doing things recursively. Because for me, I have to be able to picture an algorithm running, and even with code, sometimes that's very difficult. But thinking about stacks and activation records, then that kind of helped me. So hopefully that will help you. So the next section will be more advanced. If you feel like that's a little bit over your head, then you can stop the video right here. Otherwise, hope you enjoy the next section. So seeing the code sometimes is not enough for people to really grasp what's going on. So let's actually get down to the nitty-gritty of what the computer is actually doing with the code you just saw. All right, I'm going to give you a new term today. It's called activation record. Activation record. And if you know a little bit about computers, what you know is that when we call a function, right, we are telling the computer, hey, I've got this function, it's got some variables in it, I want the computer to do something. So it's like kind of like its own little block of code, right? It's its own little world. All right, and then the computer runs the function, and then the computer gets it to the end of the function, and then it's done. What happens with recursion? With recursion, what ends up happening is that you call the function first. So we call find subset, find sub with 1, 2, 3, 4, right? Then with recursion, we end up saying, okay, cool. Then we'll call find sub with just 2, 3, and 4, the subproblem. And then we call find sub again with just 3 and 4, then with just 4, then with nothing. Well, what's happening in the background here, all right? Because we're calling the function's calling itself over and over until it reaches the base case, in which case it doesn't call itself anymore. We don't have the function refer to itself anymore. Okay, that's why the base case is so important, because these function calls would go infinite if we didn't tell the computer to stop calling itself. What I want you to kind of bend your brain a little bit is, I'm going to move all this out the way now, is when we call a function, we create what's called an activation record. All right, the computer has to keep track of what functions you call and what order it should deal with them in, especially with recursion, right? Because recursion is referring to itself. All right, let's think about the first one. I'm just going to call it find fs, okay, for find sub, just to make this a little shorter. And it has an array 1, 2, 3, 4. All right, so we have that. In the code, remember that we took off the first number, 1, and then we recursively, we call it the function call itself with 2, 3, and 4 as the arguments. Okay, what happens is that the function doesn't go any further, right? That was like one of the middle lines. The function calls itself. It's like, oh, okay, cool. I've called myself. I'll create another activation record on top of the previous one. Now we've got find sub 4, 2, 3, and 4. Cool. I'll create another activation record with just 3 and 4. You see what's going on here? It's a stack. All right. I'm going to just use dots to say all the ones in the top, and then eventually we get to find sub of just a blank array. Now at this point, right, we programmed the computer to not call it the function itself anymore. Okay, that's not a thing anymore. So once the computer says, oh, okay, cool, you'll return something, the return keyword is important here. The return keyword says the function's done now. The function's done now. There's no more to see. Here's your value. Okay, awesome. We have our value. Our function's done. Pop this off the stack. Okay, and then what will happen is that it will come back to the previous function. So the previous one from the blank array would have been fs of 4. Okay, so it would be sf of 4. Well, what will happen is it will come back to the line where it last called the function and then continue on from there and then return something, right? Well, once this returns something, what happens? Well, it pops off the stack. The activation record pops off. We're done with it. We returned a value. And then the information will come back to the next layer, and then the next layer, and then the next layer. By the time we get to the bottom layer, we would have popped off all the other ones. This would be done, and this would be done, because we've already had a return statement. Return means the function's over with. Go home, everybody. By the time we get to here, all the returns from the previous functions would have trickled down all the way to this function. And then all the information that we got from all the activation records and all the functions above it would trickle down to the bottommost thing on the stack, and that would have all the information it needs in order to return to give us the information for the problem. That's how I think of recursion. So I have to really work in my head that it's building up a stack, one on top of each other. And each of those is an activation record that the computer uses to keep track of what functions am I working with, and in what order should I run these functions. And it just basically puts the newest stuff on top and the oldest stuff at the bottom. We use return to basically say, hey, the function's done now, and here's your data. Right? Have fun. And then, because we're using return, each of the activation records, the functions, can pass back data. So this is what it means when I say sub-problem. All right? Because if you think about it, what we essentially did was we took this bigger problem, how to find all the subsets of 1, 2, 3, 4, and we changed that into find the subsets of just a blank array, plus find the subsets of just 4 in a blank array, plus find the subsets of, you see how this is going? Of, 3 of 4, blank array, 3 and 4. All right, see how this is working? 3 and 4, excuse me. This should be 3 and 4. So we just and then plus the next one. So we build each of the little small problems, and then we smash them together at the end, and then we get our final result. This was a little bit more complex, so that if it's still a little bit shaky to you, kind of watch it a couple times, maybe take out a piece of paper and draw the stack yourself. I'm very visual, so I have to be able to imagine the algorithm or be able to draw it out in order for my brain to wrap itself around it. So if that was a little bit too in the weeds for you, I completely understand. And if the previous explanation was enough, that's great. But this allows us to kind of dig a little bit deeper. And I always find digging a little bit deeper into how things work will actually help you understand it better. Well, hopefully this helped you with recursion, and that we will be able to do more videos in the future with recursion. If you like my videos on data structures and algorithms, or anything else in my channel about Java, C#, any other programming languages, of course, please like and subscribe. There'll be plenty of more content like this in the future.